we were just drinking coffee out there and chatting about Apple versus Android versus all the stuff that's going on, PC versus Mac in terms of overall performance. Then we got talking about into CPUs and GPUs. And at some point we said we should really be on camera. And then we started talking about differences in games within the same generation of console, which is a super interesting thing.
Yes.
So your example here was Halo versus Halo 2.
I think that's where it's most noticeable because it's a lot of times, like Halo 3 came on a totally different system. They started getting into other things like that. But the jump from Halo 1 to Halo 2, both in game physics and in graphics, was such a huge jump.
Yep, exactly.
And it was all on the same system. And I was talking about whether or not that was a issue of them not having a good understanding of what the box was capable of when they first were programming the original game, or if it was maybe a lack of resources because they were a smaller company at the time before Halo's success and they brought in all that money. Or was it more that they were learning how to maximize the efficiency of what that machine was capable of, and they had a lot less redundancies
Yep, exactly.
by the time Halo 2 came out. And so I'm not sure.
Yeah.
Those were my theories that I posited to you, and you're being much more of a computer expert.
Yeah. And just, assuming we post this, because this would be a fun thing to post. I am not in the depths exactly of game programming, just as a quick disclaimer, but I want to explain to you kind of the mechanics of how these things layer up, because I think that will tell you a lot. So when you think about creating a game, there are layers to how the game works. And this is the same in computer processing. You have your code, and your code interacts at a certain level. And then eventually that gets down to processor instructions where the processor does the work, whether that's a CPU or a GPU, right? And then, managing which one does the work and how efficiently that work is done, etc. There's a lot of things that go into game design in terms of efficiency and the user experience, which we were talking about with Apple earlier. There's specific targets here too. So you need to be able to generate a certain frame rate. Otherwise, the experience for the person playing the game is bad, right?
Right.
And so typically that target back at that time would be in the 30 frames per second range. We could talk about that ad nauseum, I'm sure. But let's use 30 for the sake of this. And you have a lot of experience in film, so 24 frames, 30 frames, depending on the format of video you're shooting. That's pretty normal, and that's what the human eye wants to perceive. And it's pretty unusual to have a movie that is running at 15 frames per second or, 82 frames per second. That would be really strange, right? So you have a target that you need to be able to hit, and you need to be able to maintain that target no matter what's happening on the screen, no matter what's happening behind the scenes, maybe off screen. So there are a whole bunch of different tricks that go into this. A lot of that is handled by something called the engine. And so game engines, it used to be that when you were making a game, you would make your game engine. And then you would start to build the game on top of that engine. And then as you ran into things you couldn't do with that engine, you would either need to rewrite the engine, bring in add-ons to the engine, where other companies have already solved that problem, right? Or get really creative about how you accomplished what you wanted to accomplish because your engine doesn't do it. So for instance, if you're playing a game with a lot of firearms, right? Your engine is going to involve projectiles moving or maybe teleporting, right? Depending on the age of the engine, what it looks like. It might be that when you fire a gun behind the scenes, the game is just saying everything in this vector immediately gets hit until it runs into something that's non-penetrative,
Mm-hmm.
right? Something that particular projectile can't go through, and it's instant, and there's no travel time, and there's no ballistic arc, and it's just boom, right? It's a laser beam that you shoot until it hits something instantly. Some games there's an arc that's built in. Some games it's on a per weapon basis. There might be travel time, there might not be travel time. That is dictated by your engine, the capability. And if you have a game that just points a laser beam and says, I instantly beam something down that vector until it makes contact. If you go, okay, now I want to put in some sort of grenade launcher that you can launch at an angle. Well, that's not written into your engine. You don't have the physics for that. You don't have, and so then you have to go back in and build that. The engine determines things like how your characters move, what's allowed, what's disallowed, and this is where motion capture now is providing us all sorts of cool things that we can add. When you have an engine that allows motion capture and you add motion capture, you can create very human movements with, in the end, less work for the developers. So anyway, the thing about those engines is as you start to layer things on top of the engine that you want to do that the engine doesn't do naturally, so you either have to recode it or you're accomplishing it in a creative way, that creates more processing strain on the system. So in an earlier game like the original Halo, right, the engine did what it did, and it did what it did well enough, but they had a whole bunch of features that needed to be added for Halo 2. And they had a lot of time to improve upon that engine. And once the engine was better, all of these things were built in and done at a lower level. Instead of being scripted on top, they were able to be done lower down, which is more efficient. And one of the things you see with more modern games is that the engine thing is no longer something that you usually do on your own. Usually you select an engine and you start there, right? I already have an engine. Back in the time of Halo and before that, the people who built engines were rock stars. They were amazing because they set the tone for the efficiency of everything, right? But now we have Unreal, right? Unreal
Is
Engine.
that like independently produced that other companies can then license the engine from them, or how's that
Correct.
work?
That's usually how it works. So
Okay.
Unreal Engine right now is kind of the big one.
That's one I've heard of.
Yep. And then Unity as well is another
Yes,
one that you've probably heard of. There are more, but those are kind of the two bigger players. And when you're building a game, you want to select an engine that is able to do pretty much everything you want to do. But yeah, a big reason. So some of it is understanding exactly what the hardware can do. Some of it is updates to the engine. Some of it is kind of people figuring out cool tricks that you can do to, hey, if you want to accomplish this particular lighting effect and you do it this way, it takes 60% less resources than doing it this way. And then as the developers figure out those tricks of how you optimize performance, they can continue to accomplish that 30 frames per second target. Because that is the thing. If you want to do something really cool, but it drops your frame rate to 20 or it drops your frame rate to 15, that's usually going to be considered unacceptable. Right?
Of course.
So, and then, one of the tricks is I only draw the things that are in front of the character right now. I don't draw anything off to the side. Then you can get some interesting things where I turn, and if I turn too fast, the computer or console is not ready to draw this, and so you get all sorts of weird artifacts and tearing and
Yeah.
those sorts of things. So yeah, so a lot of it is related to engine. A lot of it is related to efficiency tricks. And then some of it is just related to the fact, the amount of investment you can make in the art, because there are times where the art is just very basically done because the mechanics are more important. And yeah, so when you make a whole bunch of money and you go, okay, we're going to make this game again, we can make all the mechanics happen, and we have more money to spend on the art, so this game is going to be beautiful, right? That is also a pretty normal thing. That
Are they able
yeah.
to like
Mhm.
carry some of the same assets and things and like engine, like build, obviously not the same engine, but like
Mhm.
build off of that one?
Oh yeah,
So
yeah.
like when Halo 2 comes out, they are getting a bigger budget because Halo was such a massive success.
Mm-hmm.
And they also are able to spend that money in different areas
Mm-hmm.
because some of the stuff they can still carry over from the money they spent on Halo 1
Right.
and build off of. And instead of building an engine from the ground up, maybe they spend 50% as much time modifying the engine.
Correct.
And they can spend that money elsewhere.
Yeah, and I would just say think about it this way, right? So if you have a studio, I'm going to throw out some round numbers just to be silly. You have a studio of 200 people, and 10 to 20 of them are working on the engine, right?
Mm-hmm.
And then all of a sudden, your game launches, the engine's running really stably, right? Because it had to before the game came out. There's a few updates that those people need to make, that those engine folks need to make in order to make everything run smoothly, for multiplayer or whatever, right? There might be some post updates, but they're probably working on the next game first. And they're talking to the designers of the next game about what do you want to be able to do? What kind of story do you want to tell? What kind of set pieces do you want to have? Because just like in movies, a lot of games have set pieces. They're like, okay, we're gonna do this really cool thing. We're gonna do this really cool thing, and then here there's gonna be this thing. And the classic joke is, you have to have this giant explosion, and you have to have this particular like car scene, and all of those things matter. Like, okay, you want to have a driving section. This engine doesn't have driving mechanics, so I need to build those. So what does your driving section feel like? What is it? What do you want it to feel like? Because there's a lot that goes into building something that drives in this engine that doesn't have driving yet, right? Mm. Well, that engine team, back when the companies were building their own engines for their own games, that engine team going into the sequel, you still have 10 to 20 people. You didn't lay off your engine team. You're keeping that same team. Your engine functions. They can 100% just invest in improving it. And these folks are not artists. It's very, very unusual to have somebody who's super deep in like engine mechanics, engine efficiency, who also likes to draw on the weekends, like that,
Right.
that is making assets that are high enough quality that you want to put them in your game, right? Smaller studios, yes, absolutely. You have people that do everything, but at the bigger studios, so you get massive engine improvements. And if they're really, really focused on like, oh, how can I get the most out of this hardware? Yeah, absolutely. You're going to see enormous jumps in what that hardware can do, because they know that they're going to be on that hardware for 5, 7, 10 years, right? This was very pronounced with Xbox for sure. This was very pronounced with PS3. Mm-hmm. PS3 was quite unique hardware, which kind of makes me sad because a lot of those PS3 games will, never come back. You have to have a PS3 to play those games.
Yeah, they haven't even ported a lot of those games to
the can't.
PlayStation shop.
They can't, because of the way they were made, because of the hardware they were made for. It's it's a completely different animal. The PS3 was a wild, wild machine.
Why don't you explore that a little bit? Because I'm not really familiar with it.
Oh boy. So okay, this is one that I haven't looked into in a while. So let's see if I can find exactly. We're going to the very reliable Wikipedia. All right. So one of the PS3's biggest things was their CPU. And it's kind of a strange CPU. So it includes a 3.2 gigahertz PowerPC based power processing element and 7 synergistic processing elements. After production, all of these different elements are tested, right? And if a defect is found in one, it is disabled. Amusingly, this is also how they make GPUs. They make GPUs, and then they test the cores on the GPU, and if some of the cores don't function fully, it's a lower tier GPU. There's a whole lot of fascinating stuff that goes in there. So in this particular time, right, this is Xbox 360 time, you had a PlayStation with a PowerPC based processor. So this is not a typical Intel processor. So you would need virtualization to port these over, but it's an 8-core processor, and the way that it was set up, it required, for you to get the full power out of the thing, you had to figure out how to use those different cores in specific ways. Let me see. It's been a while since I looked into this. Yeah. Anyway, I guess the main thing is that the processor architecture they used with all of the cores, it was weird to have multi-core in such a big way at this time. And the way that they handled efficiency on the system was just unique to the PlayStation 3. It wasn't like that in the PlayStation 4. It wasn't like that in the PlayStation 2. It wasn't like that on any of the Xboxes. And it wasn't like that on Nintendo hardware. Nintendo hardware is kind of its own deal, right? But so you could not play PlayStation 2 games on the PlayStation 3. You cannot play PlayStation 3 games on a PlayStation 4. Excuse me. And you can't really port a PlayStation 3 game directly to PC, because even a significantly more powerful PC can't do what the PlayStation 3 did with the way it was handling its processing. And because it was a PowerPC based processor, you would need some significant virtualization in order to make that work. So you're taking out the lowest level, most efficient, and then you're adding layers of virtualization on top of that, and then trying to run it as if it's the lowest level. Some of those PlayStation 3 games, I didn't own a PlayStation 3, and I played a few PlayStation 3 games that I really loved. And I think it's kind of sad that we're unlikely to have those ported. Then again, it is an older it's an older system, and a lot of people are going to let it go. I just hate to see art like that die.
Maybe this is too early to ask things like this, but like theoretically they could kind of reprogram the game onto like a new engine or something and like remake it for a different
Course.
thing.
Of course. There were...
Do you foresee that being an application for AI one day? The AI might be able to take, this is the existing program, this is the engine I want to port it to. Can you and then have it reprogram onto a new engine? Or is that something that's always going to have to be human? Is there too many? Obviously, AI, where it is right now, I don't think is capable of that. Is that some? But AI is also advancing very rapidly. So
Yeah. Well,
that seems like a simple enough thing. It's just translation to some degree, right? Like it's not.
yeah. AI is really good at coding tasks, and AI is really good. AI can be really good at finding methods of accomplishing things that humans haven't thought of, right? AI is discovering new math. AI is discovering new ways of solving pharmacological problems and like understanding the human genome, because it just has a larger. It can hold more things at once than
can hold
humans.
more ideas in its head
Correct.
than a human being can, and a lot of new ideas is a recombination or reimagining of prior existing ideas.
Correct. Exactly. So this is the thing where a lot of new ideas are shockingly simple, but discovered by people that combine old ideas in novel ways, right? And so, yeah, is this something AI could do? Yeah, I think eventually that's true. Is it something that AI will do? That's a whole other thing. Yeah. Then also, are these companies still in operation? Do they see any potential upside for porting these games somewhere else, right? And who owns the IP? And those things in combination are really complex. A lot of video game IP, when developers get shut down, if that IP isn't already owned by a publisher, a lot of that IP gets sold in bundles. And then there's a variety of reasons legally for those companies to not allow that IP to be used. When they buy bundled IP with like a whole bunch of different titles, they really want to buy one or two titles. They get those one or two titles, they develop those titles, and they shelve the rest of them and never allow them to be touched, because it's fiscally unfeasible.
Right. For now. Because all these IP copyright laws have expirations. They do. I mean, Disney just lost the rights to the very earliest drawings of Mickey Mouse. So
yes, but copyright and patent, there's much different timeframes here, and I don't know who's going to be going.
Can't patent. Like the actual IP though. That's
correct.
Inventions.
Correct.
Right? So that is a different.
It is a different thing.
System.
But here's why I'm calling it out. Patents have a shorter time frame,
right,
than copyright. And so IP rights, unless they are explicitly abandoned, they last a long time. And the question is anybody going to care about art created on this particular platform once that IP actually expires in the 2050s, right? Ish. So, yeah, I don't know. We'll have to see. But yeah, so custom processors, I do, that's, PS3 was custom processors built only for the PS3, maximized efficiency for the PS3, not like anything that was being sold for computers. The closest thing to what they were doing here for one of the processors was Mac. This is before Mac moved over to Intel, right? The closest thing was the Mac processors from the aughts, but they were also doing special stuff on top of it. Well, then the next year, if I remember properly, the year after the PlayStation came out, Mac moved over to Intel. Right. And so most computers were running the x32, x64 architecture. And yeah, I mean, pretty much everyone's gone this way, where PlayStation 5 now, It's easy to design for PlayStation and computer at the same time. Xbox is very easy to design for PC and Xbox at the same time. And the Xbox pretty much runs PC hardware.
Right.
And they're moving towards, the next generation of our console is just going to be a PC. It's just going to be a very streamlined,
PC,
consistent PC
for gaming and runs an Xbox OS.
Yes, and runs an Xbox OS, but also can do things that a PC can do. They're talking about,
Xbox will be like an app essentially in the PC. You open your Xbox app to play your Xbox games.
Yeah, that's what it sounds like. Now, I'm not super close to it, but that's what it sounds like. And one of the things they're talking about is making sure that Steam is available on the next generation of Xbox. At which point, I suddenly have hundreds more Steam games or hundreds more Xbox games, right? And my children will be able to access some of my core memory games, which I think is really, really fun. That's really cool. I don't know how all the licensing is going to work for that because my kids are going to have their own Xbox accounts, but I can sign in as me and let them play some of those old school games.
Video game systems come full circle and everyone's just a PC gamer again. They're fulfilling the prophecy.
Yeah. Well, it's interesting because, PlayStation is still kind of chasing a lot of the exclusives. So there's a couple of companies that are still chasing exclusives. And, Nintendo's doing it. Obviously, Sony's doing it with their PlayStation, where they're buying exclusive timing, where essentially the first year it's only available on PlayStation 5, and they're trying to drive up PlayStation purchase with that, which is all well and good. Go ahead and do it. Epic Games, the owners of Fortnite and the Unreal Engine, right? They are doing well for themselves, you could say. They're also buying lots of exclusives to prevent them from going on Steam. And there's lots of fascinating dynamics there. Epic Games has been in huge fights with Apple about their whole ecosystem, just to relate it back to what we were talking about out in the lobby. So that, and some of those legal cases have been interesting to watch over the last few years here. So we'll kind of see how that goes. But I like the way that Xbox is kind of pushing towards, hey, we're going to release essentially a PC. We're going to give you access to all of your PC games. And when people develop games for the Xbox, we're going to create easy paths for them to release it on Xbox and PC. And then when you buy a title from our store, from the Xbox store, you're buying the PC and Xbox title, right? They're really trying to lean into that more and more. So people who play in front of a TV at home, and then people who want to play at a computer, it's buy once, play both places. So that's already kind of what they're doing. They're moving more towards a subscription model, which has its own headaches and problems. Yeah. But it's the state of the industry here is interesting.